Students, welcome back to our YouTube channel. My name is Teacher Mati, and today I'm going to teach you about oil drop experiment. So I'm going to give you a trick on how you will calculate the size of the oil molecule. When an oil drops on the surface of water, it spreads and forms a layer of a circular cross-sectional area. The layer formed is cylindrical in nature, so I'm going to give you a trick that will help you calculate the size of the oil film. And remember, when you ask the size, it means the thickness. Of that film. Now we are going to solve this question, which reads: suppose an oil drop has a volume of 0.1 cubic millimeters and forms a film with a radius of 10 centimeters. Calculate the thickness of the oil film. Now, before we solve this question, we are going to look at a number of assumptions that we make during oil drop experiment, and these assumptions are going to help us calculate effectively. So the first assumption made during this experiment is that an oil drop is spherical. So the oil drop, before it spreads on the surface of water, it has a spherical shape, and we know that the volume of a sphere is given by 4 divided by 3 pi r cubic. So we are going to use this formula to calculate the volume of the oil drop, or this formula helped us to give us the volume, which is 0.10 cubic millimeters. The second assumption is that the oil patch has a circular cross-sectional area. Now when the oil drops on the surface of water, it spreads and forms a layer of a circular cross-sectional area, and that area is given by pi r square. But the layer itself is not circular. It's not a circle. It is in form of a cylinder, and remember, a cylinder has the thickness or a height, and in fact that is the one we are asked to calculate. And remember, the volume of the oil drop is the same volume that has spread on the surface of water, meaning the volume of the oil drop will be equal to the volume of the oil patch. So this oil patch has a thickness or the height and has a radius given by r. So we are going to use small letters or small letter r to denote the radius of the oil film. Now we have said that the volume of the oil drop will be equal to the volume of a cylindrical oil patch, and remember, the oil drop is spherical and the oil patch is cylindrical. So the sphere is given by 4 divided by 3 pi r cubic, and remember, we use the capital R for the radius of the oil drop, and we use the small r for the radius of the oil patch. And also the volume of the cylindrical oil patch is given by pi r square h. So 4 divided by 3 pi r cubic as the volume of the sphere is equal to pi r square h, or t. H is the height or thickness in this case. So making the height or thickness the subject of this formula, we get the thickness to be given by 4 divided by 3 pi r cubic divided by pi r square. And remember, these radiuses are not the same. So this r, capital R, is the radius of the sphere, and small r is the radius of the circular patch. So that's why we usually say most books have this direct formula that the thickness or size is given by the volume of the oil drop divided by the area of the oil patch. But I've just shown you how this formula comes by. So from our question, we know that the volume of the oil drop is 0.10 cubic millimeters, and we can calculate the area of the oil film. And remember, we are given the radius to be 10 centimeters, but we must keep the units the same. So the simplest way is to convert the radius of the circle to be in millimeters, and that one is 100 millimeters, and the area of that circle will be given by pi r square, that is 22 divided by 7 times 100 millimeters times 100 millimeters. So this one will give you the thickness to be 3.0 times 10 raised to power negative 6 millimeters. So this is the thickness of the oil film. So the oil film had a cylindrical shape, and in fact the thickness is the height of that cylinder, but that cylinder has a circular cross-sectional area which we calculated using this formula pi r square.